The first thing that we need to deal with in this problem is the issue of the mosquito nets. Now we know that at first there are no mosquito nets in place at all, so we're going to create this variable called net factor and initialize it to 1. We know that after 100 days, net factor is reduced by bite reduction by net, this constant that we created up here. So we add in this if statement right here, saying that after 100 days, net factor is reduced by 0.9, which is bite reduction by net. Remember that this is basically the probability that a person is going to be bitten. It makes sense that if you add in a mosquito net, the probability of you being bitten will go down. Now for implementing the forward Euler method with the infected populations, both human and mosquito. For the number of infected humans at the next time step, we of course need to start with the number of infected humans at the previous step. To this, we're going to add on the number of people that are being added to the infected population. We're going to subtract the number of people that are moving out of the infected into the susceptible population. Let's first think about the term that's being added to the number of infected humans. We take the probability of a person being bitten, which is net factor, times the number of bites per day and per mosquito that a person gets. Also multiply that by the number of infected mosquitoes, and then we multiply this by the fraction of the total human population that is still susceptible. Also multiply this by the probability of a mosquito transmitting malaria to a human. Now on the other side of the coin, we have the factors that move people away from the infected population and back into the susceptible population. This is a very simple term. We simply take the number of people that were infected at the previous time step and divide this by the time that it takes a person to recover. Remember that all of that was multiplied by h and added to the number of people infected at the previous time step. Now let's take a look at how the infected mosquito population is changing. Since we're using the forward Euler method, we start with the number of infected mosquitoes at the previous step and then add to this h times a bunch of other things. Now to find out how many mosquitoes are moving into the infected group, we start with the probability of a mosquito biting a person, which of course might give the mosquito malaria as well. Multiply this again by the bites per day mosquito. Multiply this by the number of susceptible mosquitoes and the number of infected humans. We then divide this by the total number of humans and multiply the transmission probability from human to mosquito. If you remember the drawing that I showed earlier on in the video introducing this problem, I told you that the only way that mosquitoes can no longer be infected is to die. They don't move back to being susceptible. This means that the only thing that is going to decrease the number of infected mosquitoes is death of mosquitoes. So what we subtract from this entire expression is 1 over the mosquito lifetime times the number of infected mosquitoes at the previous step. I know that that was a lot of constants and variables to keep track of, but great job if you were able to fill all of this out. Now let's take a peek at what our final graph for Unit 3 looks like. Now in this graph, the blue curve shows the fraction of humans who are infected, and the green curve shows the fraction of the number of mosquitoes that are infected. At first glance, it might look like there are many, many more humans infected than mosquitoes. But remember that because this is fraction, this doesn't actually show us plain numbers. In fact, we started with 10 to the 10th mosquitoes, but only 10 to the 8th humans. So even if a much smaller percent of the mosquito population is infected than the human population, the mosquitoes are able to infect such a great portion of the humans because there are so many more mosquitoes than there are humans total. We can see that the number of both humans and mosquitoes infected at first increases sharply and then levels off and stays at a very high number. However, as soon as 100 days hits and we introduce the mosquito nets, the number of infected in each population starts to decrease sharply. We can see that our mosquito net idea was definitely very effective for helping slow the spread of malaria in the human population, as well as the mosquito population. Great job on all 3 problems in Unit 3. I hope you found this discussion of the SIR model and its variations interesting.